Welcome everyone, back to the channel. Podcast. Today, we're tackling a question that's probably crossed everyone's mind at some point. Why is the sky blue? The answer lies in a cool phenomenon known as Rayleigh scattering. But before we jump in, let's ask ourselves. Have you ever noticed how the colors of the sky change during sunrise and sunset? What do you think causes that?
Alright, to understand Rayleigh scattering, let's first chat a bit about light itself. Imagine sunlight as a wave of different colors, each with a specific wavelength. Now, picture light encountering tiny particles. This can be anything from dust motes to air molecules.
When light hits these particles, what can happen to its path?
Exactly, it can get deflected. This deflection is called scattering. Now, the size of the scattering particle relative to the light's wavelength becomes crucial. Here's where things get interesting. Rayleigh scattering specifically refers to the scattering of light by particles much smaller than the wavelength of the light itself. The key takeaway here is, the amount of scattering is inversely proportional to the fourth power of the wavelength. Let's unpack that.
In simpler terms, what does that mean for different colored lights, with different wavelengths?
Right on. Shorter wavelengths scatter more readily than longer ones. Sunlight hitting our atmosphere is a beautiful blend of colors, each with a distinct wavelength. Blue light, with its shorter wavelength, gets scattered much more effectively by the air molecules, much smaller than blue light, compared to red light, which has a longer wavelength.
So, how does this preferential scattering of blue light play out in the sky?
This is where the magic happens. The scattering of blue light in all directions fills the sky with the vibrant blue hue we see during the day. At sunrise and sunset, the sunlight travels a longer path through the atmosphere. This extended journey allows more scattering of the shorter wavelengths, blue and violet, by air molecules. The remaining unscattered light, rich in longer wavelengths like red and orange, reaches our eyes, painting the sky with those breathtaking sunset colors. Rayleigh scattering isn't limited to just the sky. It plays a role in various natural phenomena. For instance, the reddish color of Mars is partly due to Rayleigh scattering of sunlight by dust particles in the Martian atmosphere.
Rayleigh scattering is a fundamental concept in physics, explaining not only the blue sky but also a variety of optical phenomena. By understanding how light interacts with particles, we gain a deeper appreciation for the wonders of the universe, right from the sky above us to the distant reaches of space. Are there any other questions you have about Rayleigh scattering or the science behind the colors we see in the sky? Feel free to leave them in the comments below, and we can explore them further in a future episode.